first thing first, what do you all know about quadratic curves?
Y equals to mx.
That one, y equals to mx plus c is a straight line curve. But what about curves? Okay, so we have a ax squared plus bx plus c. That means it is always highest power 2, the degree or the power. Okay, is 2. Then you will have a quadratic curve. What else do you know about quadratic curves? What else do you know about quadratic curves? If it's a negative value for the coefficient of x squared, then it will be a frowning curve, which we call it a maximum curve. Okay? But if the value of a is positive, you are happy. So it gives you a minimum curve. Okay, in fact, these shapes, they have a special name for it. It's called parabola. Okay, so they are called parabolic curves. They are either a smiley curve or a frowning curve. But you don't use that terms in your answer. It's a maximum or minimum curve. So if it has a maximum point, then it's a maximum curve. If it has a minimum point, it's a minimum curve. Okay, what other things you know about quadratic curves, functions, equations? Sorry? So when we are trying to solve it, when we put it on the curve, this is where your x-intercepts are and your y-intercept. So there are certain cases where your curve is above the x-axis and it has no real roots, remember? Okay, but there is also an instance where it will cut both the x-axis at 2 different points. So this is the case where there is 2 real roots because there's 2 intersections. One here, one here. Then there's a third case. Okay, sorry, I squeezed so many things there. Okay, there's a third case where it turns at that 1 point. So this is 1 real root only. 1 equal and repeated root. So these are the 3 cases that we have seen before when we learn 1.3, the curves. Okay, what do you want to know about it? When we are learning sketching, is there anything you want to know about it? What do you all think is important when you sketch? The minimum or the maximum point, right? Where it is. Okay, the intercepts. There could be y-intercepts and the x-ones. Okay, where it cuts the x-axis and where it cuts the y-axis. And then of course the last one is the shape. Whether it's smiling or whether it's frowning. So just by this middle portion here, you already roughly can guess that you will need a method to find the maximum minimum point. You will need a method to find the intercepts, and then you need to determine the shape. So with all this, your curve comes out. Okay? So when we are sketching, okay, this is the part that we will come back to it when we learn it. But these are the main things that you need to consider when we sketch. Okay, so it will be good that you are always thinking about what you have learned before, what is it that you are going to learn. Okay, so that you can draw connections. Okay, some of you still copying. Hope you are not very tired from your camp. The what? The soft copy is in the Google Classroom. 1.6. Just download it. Okay? Not yet. Okay, but with that being said, right, we still need to learn this. But for the past 2 to 3 years, O-Level hasn't tested sketching. They test plotting, but they have not tested sketching. But you still need to know the skills. Okay? Another thing to note is next Monday onwards, you can purchase your 10-year series from the bookshop already. Okay, I'll let you all know how much it is. Then you just prepare the money, go there, and then buy from the bookshop. Okay, I've already ordered for the whole class. Okay, next one is you are going to see your equation in these 4 ways. Yeah, yours is topical. You don't buy yearly. Yearly belongs to the Sec 4s. Okay, so this one, these two are called the factorized form. Okay, any quadratic equation you are given, you can always factorize it into a product of 2 roots. Okay, 2 linear factors. And then sometimes there may be a negative sign in front, sometimes no. So this just means there is a positive 1, this is a negative 1 in front. Okay, so with a negative sign in front or not. Or you can also express the quadratic equation in the form of completed square form. Whatever equation I give you or expression I give you, you can always either factorize it. If can't factorize, you can complete the square. So you will only see these few forms, no other ways already. So again, this is positive 1 in front. This is a negative 1 in front. Okay, so every equation that I'm about to show you, you will either see it in factorized form or in completed square form. If I didn't, part A, I will ask you to factorize or complete the square first. Then part B, we sketch. Okay, so factorized form is good for finding the intercepts first. Okay, and then completed square form will tell you the turning point first, whether it's a maximum or a minimum point. Okay, so different forms will tell you different points first. So it depends on which we are given. Okay, can let's try the first one. Done? Silent means consent, right? Oh, not yet. Okay, this one. Okay, I'm not gonna ask you to plot it. I will want you to sketch it directly. Okay, so this one you can go back and revise your plotting. Okay, what is the thing that I want to do is the sketching part. So this one is for revision of plotting. So you can go back and plot. Okay, but if you don't want, it's also fine, because plotting you should know already. I have checked your. It's just your skill that makes some mistakes here and there. Okay, so first thing first, I look at the form that is given to me. This is what form? Factorized form. So that means I will have to use this to find my intercepts first. So when they say sketch, you need to find a few things first. Number 1, you want to determine the shape of the graph, which I told you just now. You look at the sign in front here. Or rather, if you expand it out fully, you will see that this is your quadratic expression. So the coefficient in front of your x square will determine whether it is positive or negative. So in this case, you know it's positive 1. So since your A value is 1, which is positive, you know you are happy. The shape of your graph is a minimum curve. So you know the shape is a minimum curve. So like all factorized form, you find x-intercepts first. So x-intercept means it's going to cut here, right? So how do I find these two values? What values of y should I sub in? Yes, can you see that this line is where your y is equals to 0? So when you find the x-intercept, you need to always sub y as 0 and try to solve it. So if you look at your equation, if you sub y as 0, you will have two solutions for x. One is x equals to minus 2. One is x equals to 1 when you solve it. So it's subtly telling you that one point here is minus 2, one point here is 1. Okay, but ignore the sketch here. I'm just trying to illustrate my point. Okay, so that's the two intercepts. Okay, next one, I want to find my y-intercept, which means that my graph will cut the y-intercept, the y-axis somewhere along the vertical line. So this happens when my x value is equal to 0. So when I want to find y-intercept, I will sub x as 0 into the equation. So the same equation, but now my x is 0. So just key the whole thing into the calculator, and then y value is negative 2. So that means it cuts here at negative 2. Okay? So after you have found your x and y intercept, you want to know where is the line of symmetry. So remember, in all parabola, it will always be symmetrical about the mid value. So that means if I were to draw a middle line here, okay, this line here is the line of symmetry, and it will always be the midpoint between my two x-intercept. So yeah, it's also the same x value. Okay, so let's say these two are my x-intercept. One of it is at minus 2, the other one is at 1. So how do you find the mid value? Do you all remember the formula to find midpoint? Like last time when you learn fractions, how do you half it? Do you all remember where at set 1, you have two fractions? How do you find the mid value between two fractions? You add the two of them up, divide by 2. So it's the same thing here. You add the two x-intercepts, right? And then you half it. So this is your x-intercept, but remember, line of symmetry is a line. When it is a line, it is an equation. So you have to write x equals to the value that you have found. So you cannot just tell me, oh, the line of symmetry is negative half. You must tell me it's x equals to negative half. So in this case, this is my line of symmetry. Okay, it's an equation. It has to have x equals to minus half. Okay, lastly, the curve will always turn at the point where your line of symmetry is. So, can you see this is my mid value? And my graph turns at the minimum value where my line of symmetry is. So, the x value here is the same. I just need to know what is my corresponding y value. So, I will sub my line of symmetry. Okay, I always write LOS, short form. Okay, I will sub my line of symmetry into the equation. So these are the few steps you need to have in your mind. So if I substitute x as minus half, okay, then you can find your corresponding y value. So what should it be? Is it minus 9 over 4? Huh? Okay. So now we can start sketching. We have all the crucial points we want. So let's sketch it all. So let me mark out my first point. My x-intercept is at minus 2. So you just roughly will do. No need to be very precise. No need to use ruler. Okay, but if you want, it's fine. So this is my negative 2. And then my 1 will be somewhere here. So I mark out my 2 x-intercepts. Okay? Then using the same scale roughly, let's say this is -2. So let's say this is -1, this is -2. So my y-intercept is over here. So I'm done with my 3 points already. One is this, which I plotted. This one. And then my y-intercept here. And then there is a turning point, which is at -1/2. And then y is -2 1/4. So I know it's somewhere here. -1/2 is somewhere here. Okay, and then my other y corresponding value, I can mark out my -3. So 1/4 is maybe roughly here. So just a sketch will do. So that is my turning point here. Okay, where my x is -1/2 and my y is -2 1/4. So with the 4 points, you can sketch out your graph now. So just make sure it passes through all the points that it needs to pass through. Yes.
Why is -1 below of -2?
Because you treat it as a number line, right? So -1, -2, -3. Then 0, 1, 2, 3. So it moves upward. So -1, -2, -3, and so on. Oh, did I write?
You write 1.
Okay, I think I never write it.
Yeah.
Better. Okay, so once you mark out the essential points, your Smalley curve is out, your 2 x-intercepts, your y-intercept, your turning point. So make sure you mark out all the points correctly. And then they say indicate clearly its intercept, its turning point. But sometimes, let me warn you, they will say indicate clearly the coordinates. When they say that, you got to write down the coordinates of all these points. So this is 1, 0. This is -2, 0. This is 0, -2. And then the turning point here is this. So you read the question carefully. Sometimes they require to write down the coordinates. Otherwise, they just need you to write down the points where it cuts. Formula for turning point don't have. The thing that you need to know is you need to substitute your line of symmetry into the equation. Okay? Okay, and then remember line of symmetry must write it in an equation form. Must write x equals to -1/2. If the question say, can you draw your line of symmetry? Then make sure it's a solid line downward. Okay, cannot be dotted because they're asking you to draw the line out. And then label is equation. So this is x equals to -1/2. Okay, your line of symmetry. If the question asks you to draw. If you draw but they never ask, will you be penalized? No. Okay, so this is sketching when it's completed square form. Done? Not yet. Can I see most of the still wait. Can see or not? Can? Okay, I move on, or you're still copying? Anybody? No, Okay, let's look at next one. What if it's negative now? What if there's a negative sign in front? But you need to take note. So far, we have always been having x in front. But I can trap you by doing this. Sometimes I can trap you by doing this. Then there's no sign in front, but you can't make the assumption that it must be a smiley curve. Because if you expand this out, can you see there is a negative x squared? So it's a maximum curve. So there could be traps like this. So be careful. Just do a mental expansion and see what is the coefficient of x squared. Don't just look at this in front. Okay, don't just rely on this in front and then make the decision that must be maximum, must be minimum. So do a mental expansion. Okay, so just to address that part. Wait Okay, a quick one. One, straight away you know if you expand this out with this, it's a negative x squared. So the shape is maximum curve. Okay, x-intercept means you sub y as 0. So if you do a quick solving, okay, this one is also another trick that you need to learn. Don't work too hard. You can bring the entire negative product to the left and it makes it positive already. Don't go and expand and make life difficult for yourself. Just bring the whole negative product over, become positive, and then you solve it normally. These are the two x-intercept you have. Okay? And then y-intercept, you will sub x as 0. So put it into the equation. Key the whole thing into the calculator. It will give you negative 3. Okay, line of symmetry, we always add up the two x-intercepts. And then you half it. So these two values you add up. And then you half it. So your line of symmetry is just negative 2. Y equals to negative 2. Remember, must write x equals 2. And then the last one is the turning point. You sub in your line of symmetry. So sub in x as minus 2. You will get is it 1? 1 times negative 1 times negative. Yeah. Okay. So your turning point would be your x value being negative 2 and then your y value being 1. So this is your turning point. So with all these points, you are ready to sketch. So mark out all the points that are essential. Let's say minus 1 is here. So these are the two x-intercepts. Okay, then your y-intercept is at negative 3. So negative 1, negative 2, negative 3. Mark it out. Okay, your turning point is at negative 2 and 1 over here. So you should be able to see a maximum curve. You can always turn your paper and sketch. You don't need to be rigid. Okay, make sure it's symmetrical about your line of symmetry. And then it passes through all the points that you mark out. Okay, so they say indicate your intercept, your turning point. And then all is written there already. So you don't have to worry about it. But if they say indicate clearly the coordinates, then go and write out all this. One more extra point for that. Okay? So if you want, you can complete it with writing the equation. Okay, as a closure. $1:35. I only have 8 minutes. Okay, so we have done factorized form. How do you sketch when it has a negative sign in front or it has a negative sign nowhere? Okay, I just summarize the steps you need to take. You can just copy down. The shape can either be max or min. When you find x-intercept, you sub y as 0. When you find y-intercept, you sub x as 0. So these two are the opposites. Okay, so these are the steps when your equation given are in factorized form.
But if it's not factorized form, can I divide out?
That means extract it out. You can, but if you can't factorize, it's complete the square. The top one. Okay, when you are sketching your graph, make sure there's no hairy lines. That means don't be like an art student, right? You go and perfect the curve by drawing a lot of hairy lines. Just show confidence. One sharp and nice line. Okay, I see a lot of hairy lines. I scared. Done? Okay, then I can quickly zoom this part. Okay, just repetitive, repetitive. This one can I bring? Okay, next week I will go through your quadratic problem sum questions, PMP. I will go through your assignment, which is your HBL homework tomorrow. Okay, then we will start AMAP already. Oh no, we need a quiz, right? So after the quiz, then we go to AMAP. Okay? Done? No pen.
What's the quiz about?
We have tested on up to quadratic formula, right? So I think quadratic formula can be anywhere. So quadratic formula, your problem sum, and then sketching. Okay, basically 1.4 to 1.6. Can Okay, next is what if it's completed square form? Okay, what if it is completed square form? So the only way to make this value as small as possible is to make this thing here 0. Because if you don't make this thing, this value here 0, it will become bigger than what it's supposed to be. Because your variable is inside. So the only possibility to get your minimum value is to make sure that this thing becomes 0. Because no matter how, I can only at most subtract 4 from it, plus 5, plus 6, minus 1. That value can't change, it's a constant. But to make it the smallest possible, I need to make this thing 0. Because there's no chance that I can square a value and get a negative number. Because if you bracket square anything, it will always be positive or lowest at 0. So the minimum value I can get is to make this part here 0. I cannot go smaller than this already because a square value is always positive or equals to 0. Any bracket square is always greater or equals to 0 for any real values of x you sub in. Okay, any real values of x you sub in. So what do you think is the x value that I should sub in so that this thing 0 out? What? 1. Because 1 minus 1 is 0. So my x value is 1. And when this whole thing zeroes out, what is my y? This one, right? So my turning point is out. Okay, again, how do I make this thing 0? The second one. This has to be 4. Right? So this is 4. And then when this whole thing zeroes out, my y must be 5. So turning point can be read directly from completed square form. So this one, in order to make this 0, this has to be minus 2. And this whole thing zeroes out, my y will become 6. So this one has to be minus 6. This whole thing zeroes out. And then my y has to be minus 1. So this is the minimum value I can have if my completed square form is these 4 different equations. Okay, but why minimum point? How did they decide that it's minimum? Why not maximum? Because the coefficient here is positive 1. Right? When it's positive, we are happy, we smile. That's why it's a minimum curve. Okay? So it gives you minimum curve. So one thing about completed square form is, first you look at the shape. It's smiling because it's a positive coefficient. Second thing you do, it's turning point. You straight away jump to turning point. So turning point I can read. Can someone tell me what's the turning point of this? My x must be 2 so that this thing zeroes out. And then my y is negative 9. So the good thing is completed square form tells me my turning point first. And then if I know my turning point, I know my line of symmetry. My x is just 2. Okay? So the only difference is if I'm given completed square form, I can get my turning point first, I can get my line of symmetry next. Don't need to go and calculate your x-intercept first. But if you want, it's still fine. Okay, there's nothing wrong about it. Okay, how to find x-intercept? Again, same thing. You sub y as 0. So sub y as 0. So when you sub y as 0, oh, I heard the bell. Okay, so when you sub y as 0, you just shift the 9 over. If you take a square root, oh no, no space. Then you get plus minus 3. So the 2x-intercept will be negative 3 plus 2 are 5. And negative 3 plus, okay, minus 1. So these are my 2x-intercept. And if you sub x as 0 for y-intercept, you will get minus 5. Okay, so every other thing is the same, just that the sequence is a bit different. And then if you go and draw it out, 1, 2, 3, 4, 5. Even if you don't want to mark all these points out, it's fine. No need to even write it out. Okay, minus 1 is here. So mark out the points. And then your line of symmetry is here at 2. Your y-intercept is at negative 5. So maybe here. Okay, and then your turning point is 2, negative 9. So it's even further. Somewhere here. So with your 4 points, you join them together, then you get your curve. Okay, but of course, draw what you can manage. Don't draw it too big if you can't manage it. You can always make the one smaller so that your whole graph is smaller, and then you can manage to draw like using solid lines. Okay, so nothing very scary here. It's the same thing, but my sequence of steps change. But will there be a situation where when I try to solve y equals to 0, I can't solve it because it's negative, no real roots, right? It's possible. It just means that your graph won't cut the x-axis. That means your graph is either floating up or it's floating below. So if you see that your x-intercept has no real roots, don't panic. You can still sketch it out, just that it will float above or below without cutting the x-axis. Yes. Okay? So that's it. So if you can, go and do the next example on your own, and then your assignment is your HBL homework. Can ah? Your teacher not here yet.